give the formula for the following compounds. Sodium hypochlorite. Well, sodium is a well-behaved cation that's 1 away from the nearest noble gas, so it should take on a +1 charge. Hypochlorite is from your table of polyatomic ions, and it has a formula of ClO with a negative. Now remember, chlorate ion is ClO3 negative. Chlorite ion is ClO2 negative, 1 less oxygen. But beyond these, even more extreme, are the perchlorate ion, ClO4 negative, and in this case, the hypochlorite ion of just ClO negative. If we cross our charges, the ones simply disappear, and we end up with NaClO. Sodium hypochlorite is the active ingredient in most bleaches. Scandium-2 iodide. Scandium-2 would be Sc, with a +2 charge. The Roman numeral is an indicator that it's a transition metal. And iodide is one of our halogens. Being 1 away from the nearest noble gas, it has a -1 charge. And if we cross our charges, bringing the 2 down and the 1 down, ignoring the negative sign, we end up with SCI2. We have nickel-2 hydrogen carbonate. Your book often refers to this as bicarbonate. I tend to stick with the more formal IUPAC, which would call it hydrogen carbonate. So the nickel-2 would be nickel with a +2 charge, and the hydrogen carbonate is the same as an H+ and our carbonate of -2. If we place these together, one of the positives and one of the negatives will cancel, leaving us with just HCO3 with a -1. So the HCO3 with a -1, if we cross our charges, we would end up with Ni parentheses HCO3 with a 2 on the outside. The 2 that we bring down is for the entire polyatomic. Hence the reason we need parentheses, so that we know that that 2 works on everything inside. Finally, carbon tetrachloride. Carbon and chlorine are both nonmetals. The prefix of tetra, a numerical prefix, is also a good indicator that we're going to be dealing with a covalent compound, in which case 4, tetra, is the number of chlorines that we have present.